In this video, we're going to have a look at proof by induction, and in specific, we're going to look at matrices and how to deal with them in proof by induction questions. So step number one is always the same. You substitute n equals 1 into the expression, and you show that you end up at this matrix here. So let's do that. So m to the power of 1 would be 2 to the power of 1, which is just 2, but we'll simplify that later. And then the second term would be 3, and then in brackets 2 to the power of 1 minus 1. This term here would be 0, and this term would be 1. Now let's focus on the simplification. So 2 to the power of 1 is just 2. 2 take away 1 is 1, multiplied by 3 is 3, and then 0, and then 1. So it matches the matrix that we're looking for, so that's completely correct. We're now going to write an inductive statement, which is that we're going to assume that for when n is equal to k, this whole expression here is also true. So we can write m to the power of k is equal to 2 to the power of k for the first term. Oops, sorry. And then the next term would be 3, and then in brackets 2 to the power of k minus 1. Yeah, and then close the big brackets, and then 0 and 1. What we want to show, that's what we write next. We want to show that m to the power of k plus 1 can be written as 2 to the power of k plus 1, and essentially just replacing everywhere where there's k with k plus 1. So here we're going to have 3, and then in brackets 2k plus 1, take away 1. And then these two are just constants, so they're just going to stay how they are, 0 and 1. How do we show that? Well, we do have to use the inductive statement, this statement here, at some point to show that this is equal to this. So let's have a go about dealing with this. First of all, m to the k plus 1, which we want to show, we can split that up into m multiplied by m to the power of k. The reason for that is because we know that when multiplying indices, we add the powers together. So 1 plus k gets you to that k plus 1. Also, we're splitting this up so that we can introduce m to the power of k, the inductive statement, into this. So, oops, sorry. That will be m multiplied by all of this. So actually, I'm just going to replace m with the what we're given m is. So 2301, and then all multiplied by m to the power of k, which is 2 to the power of k, and then 3 in brackets 2 to the power of k minus 1, and then 0, 1. Focusing on multiplying these together, I'm assuming you know how to multiply matrices. If you're not sure, I will make a video about it very soon. But to get to that first term, 2 times 2 to the power of k is, well, 2 to the power of k plus 1. Plus 3 times 0 is just plus 0, so that'll just be 2 to the k plus 1. This next term here is, well, 0 times 2 to the k is 0. 1 times 0 is 0, so that adds to 0. This is the hardest one in my opinion, so let's do this sort of to the right hand side. We have 2 multiplied by everything here. 3 to the... So actually, I'm going to write this out. 2k minus 1. And then plus 3 times 1, which is 3. 2 times 3 is just 6, so we can put 6 outside the bracket. What we can then do is expand out the bracket. So we have 6 times 2 to the power of k. Oops. And then 6 times minus 1 is minus 6. And then we have the plus 3. Minus 6 plus 3 is just minus 3. What we want to express it as is in this format here. We're able to do that now because what we can do is factor out 3 from this first term and write this out as 2 multiplied by 2 to the power of k. When you do that, you can realize that, well, 2 to the power of 1 multiplied by 2 to the power of k is just 2 to the power of k plus 1. So we can replace this with 2 to the power of k plus 1. And then all take away 3. Or one thing you may have noticed is that 3 times minus 1 is also minus 3. So we can put the minus 1 inside of the bracket, and we can represent this whole expression in this format here, which is what we want to do. Again, we just keep relaying it to what we want to get to. That's why it helps to write down what you want to get to. This term here would be 1 because 0 times all of this is 0, and then 1 times 1 is 1, and so they add to give me 1. We've now shown it, shown what we want to show, and so we've done it. We've proved by induction that this matrix here is represented by this matrix here. One thing I would add though is what it says it for specifically for all positive integers n. So you might also want to include the fact that k has to be a positive integer when you're assuming this statement, just to keep everything consistent throughout the whole question. Thanks for watching the video. I hope it helped, and yeah, be sure to subscribe if it did, and like the video. I'd appreciate it a lot. Thanks for watching the video. I hope it helped. If you have any tutoring inquiries for A-level further maths, be sure to hit my website up at www.excelineducation.co.uk.